Hello friends, how are you? Welcome to my channel. We are discussing 10th class Maths chapter 2, that is polynomials. In the polynomials, in last class we have covered introduction topic. In that we have covered definition of polynomial, degree of the polynomial, linear polynomial, quadratic polynomial, cubic polynomial, what is the value of a polynomial, and zeros of the polynomial. All those topics we have discussed clearly. In this video, we are going to cover part 2, that is geometrical meaning of zeros of a polynomial. Okay, go on friends. Here geometrical meaning of zeros of a polynomial. Okay, what is meant by zero of a polynomial? You know that we have discussed in last video that a real number k is said to be zero of a polynomial p of x if p of k is equal to 0. That means if k is a zero of a polynomial p of x, when we substitute k value in place of x, we get p of k, that is the value of that polynomial is equal to 0. Then this k is called zero of the polynomial p of x. Okay. Now we see the geometrical meaning and graphical representation. Now we will see the geometrical representation of linear quadratic polynomials and geometrical meaning of their zeros. So first we consider linear polynomial. What is meant by linear polynomial? Linear polynomial is nothing but a polynomial of the form ax plus b, where a is not equal to 0. This is called a linear polynomial. For explanation, we will take one example. Let the linear polynomial be y is equal to 2x plus 3. Okay, y is equal to 2x plus 3. For this, we see the graphical representation. To explain with graphical representation, for any linear polynomial, what is the shape of that linear polynomial? Always the shape of linear polynomial is a straight line. Okay, it is in the form of a straight line. See here in this graph, it is in the polynomial, it is in the form of a straight line, linear polynomial. Okay, to represent a straight line, we need 2 points. You need 2 points. We need. How to get 2 points? Here, for y is equal to 2x plus 3, I am calculating 2 points. That is, by substituting x is equal to minus 2 and plus 2, we will get the y values. Here for x is equal to minus 2, what is the y? 2 into, it is the y, 2 into minus 2 plus 3, that is minus 4 plus 3. So I have written minus 1. And by substituting x is equal to 2, what we get? Y is equal to 2x plus 3, that is 2 into 2 plus 3, that is 4 plus 3, that is equal to 7. So for different values of x, we got different y values. So this become 1 point 2 comma minus 1, and this become another point 2 comma 7. Sorry, it is minus 2 comma minus 1, and it is 2 comma 7. Okay. Okay. So the graph of y is equal to 2x plus 3 is a straight line passing through points minus 2 comma minus 1 and 2 comma 7. So here I have taken 2 comma 7 1 point and minus 2 comma minus 1 another point. By joining these two, we got a straight line which is nothing but y is equal to 2x plus 3. This is the graphical representation of a linear polynomial. Okay. So here from this figure, we see that the graph of y is equal to 2x plus 3 intersect the x-axis in midway between x is equal to minus 1 and minus 2. That is minus 3 by 2 comma 0. So if you carefully observe here, this line touches the x-axis between minus 2 and minus 1. That is at the point minus 3 by 2 comma 0. So at this point it touches the series. At this point, it touches the, this line touches the x-axis. So that point is nothing but minus 3 by 2. And what is the y coordinate on x axis? It is 0. So at minus 3 by 2 comma 0, this line touches the x axis. So by definition of 0, what is meant by 0? 0 is nothing but where it touches the x axis. That means the value of polynomial at that point is 0. So you also know that the 0 of 2x plus 3 is minus 3 by 2, because if we substitute minus 3 by 2 value in this polynomial, what we get? See this, 2 into minus 3 by 2 plus 3, because this is the polynomial. We substitute x is equal to minus 3 by 2, what we get? 2 into minus 3 by 2 plus 3, 2 cancel, minus 3 plus 3 is equal to 0. So if we substitute x is equal to minus 3 by 2, we get this polynomial equal to 0. That means this minus 3 by 2 is called the 0 of the polynomial. So by graphically, what is meant by 0 of the polynomial? 0 of the polynomial is nothing but the point where the straight line or the graph of the polynomial touches the x axis. Okay, where the graph of the polynomial touches the x axis, it is called 0. So this point is called 0 of this polynomial, minus 3 by 2 comma 0. This point is called 0 of this polynomial, this linear polynomial, because this straight line, which is the graphical representation of that polynomial, touches the x axis at minus 3 by 2 comma 0. And by definition of 0, if we calculate, what we got? 0 as minus 3 by 2. So this point is nothing but 0 of the polynomial. That means this polynomial graph touches the x axis at the point minus 3 by 2 comma 0. So by this graphical representation, what we concluded? The 0 of a polynomial 2x plus 3 is the x coordinate of the point where the graph of p is equal, the graph of y is equal to 2x plus 3 intersect the x axis. Where this graph intersects the x axis, that is called 0 of the polynomial. Okay, understood, friends? Next we go to quadratic polynomials, that means degree 2 polynomials. So here general representation is like this. In general, for a linear polynomial ax plus b, where a not equal to 0, the graph of y is equal to ax plus b is a straight line. Okay, what we observed? The graph of ax plus 3, ax plus b is a straight line which intersects the x axis at only one point, namely minus b by a comma 0. Okay, so general terms representation is like this. Y is equal to ax plus b means this straight line intersects the x axis at the point minus b by a comma 0. Sorry, minus b by a comma 0. Previously what we have seen? Y is equal to 2x plus 3. So minus b by a means minus 3 by 2 comma 0. So it is matched with the general expression. Y is equal to 2x plus 3, we got 0 as minus 3 by 2 comma 0. Similarly, y is equal to ax plus b means minus b by a comma 0. Y is equal to ax plus b means, what is the 0? Minus b by a comma 0. So any equation of this form, the 0 is always minus b by a comma 0. Okay, that means if you take the graph, this straight line touches this x axis at the point minus b by a comma 0. If it is a y is equal to ax plus b, it touches the x axis at minus b by a comma 0. This is called as a 0 of polynomial x. Polynomial y is equal to ax plus b. Okay, understood friends? That is the 0 of the linear polynomial. Therefore, the linear polynomial ax plus b where a is not equal to 0 has exactly 1 0, namely the x coordinate of the point where the graph of y is equal to ax plus b intersects the x axis. Okay. Since it is a right line, it intersects the x axis only at one point for a linear polynomial. That means how many number of zeros are present for this linear polynomial? Only 1 0. Only 1 0 is present for linear polynomial. So, only 1 0 exists, exactly 1 0. Exactly 1 0 exists for linear polynomial. Now, we see case of a quadratic polynomial. In fact, any general expression for quadratic polynomial is ax square plus bx plus c where a is not equal to 0. This is the general expression for quadratic polynomial, ax square plus bx plus c where a is not equal to 0. The graph of the corresponding equation y is equal to ax square plus bx plus c is like this. For this expression, the graph is in the form of parabola, that is either this shape or this shape. Okay, this shape or this shape. That is depends on the value of a. If this a value is greater than 0, then the shape is like this. If a value is less than 0, a value is less than 0, then the shape is upper parabola like this. In next slide, I will show the figures. Okay, first remember this. So, what is general expression for quadratic equation? Y is equal to ax square plus bx plus c, and the shape is in the form of parabola, that is like this or like this. If a is greater than 0, then it is in the form of down parabola. If a is less than 0, then it is in the form of upper parabola like this. Now, for explanation, we will take one example. Y is equal to x square minus 3x minus 4. And as we see in the previous one, that is calculation of linear polynomial, in the same way we calculate different points for this quadratic polynomial also. Okay, that calculation is shown here. For x is equal to different values, if you take, we got different values of y. X is equal to minus 2, if we substitute minus 2 in this expression, we got 6. If x is equal to minus 1, we substitute in this equation, we got 0. X is equal to 0 means y is equal to minus 4, x is equal to 1 means y is equal to minus 6, x is equal to 2 means y is equal to minus 6, x is equal to 3 means minus 4, 4, like that. Like that we got different points. So, in this graph we take this example, by combining all these points we got a graph like this. See this minus 2 comma 6 1 point, minus 1 comma 0 another point, here 0 comma minus 4 another point, here 2 comma minus 6 another point, here 3 comma minus 4 another point, next 4 comma 0 another point, 5 comma 6 another point. So, these are the different points, minus 2 comma 6, this is x axis, y axis, minus 1 comma 0, x axis, y axis, 0 comma minus 4, x axis, y axis, 1 comma minus 6, 2 comma minus 6, 3 comma minus 4, 4 comma 0, 5 comma 6. So, I am representing all these points. Whatever the points we have calculated, I am checking all the points, and by combining all the points we got a shape like this. This is a parabola shape. Okay, here since a is greater than 0, we got a down parabola. So, this type of representation is called parabola, and it is the graphical representation for quadratic equation. quadratic equation. That is quadratic polynomial. So for this quadratic polynomial, the shape is a parabola, and from this example we have calculated all the points, and by combining all the points we got a parabola form in the graphical representation. Okay. So that minus 1 and 4 are the x coordinates of the points where the graph y is equal to x square minus 3x minus 4 interacts the y axis. So in this graph what we have seen, these 2 points, this point and this point, that means minus 1 comma 0 and 4 comma 0. These are the 2 points where this graph intersects the x-axis. This graph intersects the x-axis at 2 points, minus 1 comma 0 and 4 comma 0. So what is meant by that? The zeros of this polynomial is nothing but these 2 points. From the definition what we got, the zeros of the polynomial is nothing but where the polynomial intersects the x-axis. From this graph, the polynomial, this graph, it intersects the x-axis at exactly 2 points, that is minus 1 comma 0 and 4 comma 0. So these 2 are called zeros of this polynomial. Okay, that is what he is saying. From the figure, minus 1 and minus 4 are the x coordinates of the point where the graph y is equal to x square minus 3x minus 4 intersects the x-axis. Thus, the zeros of the quadratic polynomial x square minus 3x minus 4 are the x coordinates of the point where the graph of y is equal to x square minus 3x minus 4 intersects the x-axis. So, by seeing this table, we got at x is equal to minus 1 we got the expression 0, and x is equal to 4 we got the expression 0, and from the graph we got at these 2 points minus 1 comma 0 and 4 comma 0, the graph intersects the x-axis. Okay, this is the conditions for zeros of a polynomial. What are conditions for zeros of the polynomial? The conditions are at the point 0 we get the expression becomes 0. So at the point 0 minus 1 we get the expression 0. At the point 4 we get the expression, this polynomial expression becomes 0. That is one condition, and from the graph, this graph intersects the x-axis at that 2 points minus 1 comma 0 and 4 comma 0. So these 2 points are called zeros of the polynomial, quadratic polynomial. Okay. So this fact is true for any quadratic polynomial, that is zeros of a quadratic polynomial ax square plus bx plus c where a is not equal to 0 are positively the x coordinates of the point where the parabola represents y is equal to ax square plus bx plus c intersects the x-axis. So from this what we concluded, where this graph intersects the x-axis, where this graph intersects the x-axis, those are called zeros of the quadratic polynomial. Okay, where this graph intersects the x-axis is called the zeros of the polynomial. These 2 terms remember. This expression intersects the x-axis, those are called zeros of the quadratic polynomial. From our observation earlier about the shape of the graph y is equal to ax square plus bx plus c, the following 3 cases can happen. Okay, what we have seen, the shape of the graph is like a parabola, and what are the possibilities of these parabolas? 3 cases are exist for this quadratic polynomial. We will see that 3 cases. This is one case. Here is the graph that cuts the x-axis at 2 distinct points a and a dash. X coordinates of a and a dash are 2 zeros of the quadratic polynomial ax square plus bx plus c. Okay, this is the case where it cuts the x-axis at 2 points a and a dash. Here also a and a dash. Okay, this is same cases like this. If a is greater than 0, then it is like this. If a is less than 0, then it is like this. So in these two cases, it exactly cuts the x-axis at 2 points, a and a dash. Next we will see another case. In this case, it cuts the x-axis at 1 point only. This a point only, it cuts the x-axis. Okay. Similarly, for a is greater than 0, it is like this, and for a is less than 0, it is like this. It cuts only at 1 point. That means only 1 0 exists at for this parabola. Only 1 0 exists. That means it cuts the x coordinate only at 1 point. Okay, cuts the x coordinate at only 1 point. That means only 1 0 exists. Next, what is case 3? Case 3 is, it is in the form of like this. In this form, what happens? It is not touching the x-axis at all. It is not touching the x-axis at all. That means x-axis it is not touching means there is no 0 exists. No 0 exists. Okay, it is not touching the x-axis means there is no 0 exists. So from these three graphs, what we have seen, what are the minimum values of zeros? Okay, 0. That is no 0 case. No 0 case means no 0 exists for the polynomial. What is the maximum value case? Maximum we have 2 zeros. For this quadratic polynomial, maximum we have 2 zeros and minimum we have 0 number of zeros. 0 number of zeros. So you can see geometrically that the quadratic polynomial can have either 2 distinct zeros or 2 equal zeros, that is 1 0 or non-zero. That means the polynomial of degree 2 has at most 2 zeros. Okay, this first case is 2 distinct zeros, a and a dash, that is 2 distinct zeros, and in this case both zeros are at point a, that means zeros are equal, and this case no zeros are present for this polynomial. Okay, so what is the possibility? It is having either 2 zeros of distinct, that means separate zeros, or 2 equal zeros, that is 1 0. Equal 0, x is equal to 3, x is equal to 3 means only 1 0. For namesake it is only 1 0 only, and no 0 case. No 0 case also possible. So that means this polynomial having at most 2 zeros. The degree of the polynomial is 2, that is quadratic polynomial having at most 2 zeros. Okay. Next, so what we have seen in zeros of a quadratic polynomial, the quadratic polynomial general expression is this: y is equal to ax square plus bx plus c. It interacts the x-axis at some points. That points are called zeros of the quadratic polynomial. Okay, the shape of this quadratic polynomial is always a parabola. In that parabola, it is, if it is a downward or upward, decided by the value of a, this coefficient of x square. If coefficient of x square is greater than 0, then it is a downward. If coefficient of x square is less than 0, then it is a upward parabola. Okay. So the shape of parabola and the shape of quadratic polynomial is a parabola. If coefficient of x square, that is a, is greater than 0, it is downward. If coefficient of x square, that is a, less than 0, it is upward. What are different possibilities of a parabola? The parabola intersects the x-axis at 2 distinct points, a and a dash, and the parabola intersects the x-axis at only 1 point, and the parabola does not intersect the x-axis at any point. These are the 3 possible cases for the parabola, that is the shape of a quadratic polynomial. Okay. So from these points, what we concluded that for quadratic polynomial, number of zeros are at most 2. Okay, maximum number of zeros possible are 2. Next, zeros of a cubic polynomial. Okay, cubic polynomial, what is the general expression? General expression is y is equal to ax cube plus bx square plus cx plus d, where a is not equal to 0. Okay, this is the general expression for cubic polynomial, or precisely the zeros of this cubic polynomial is nothing but same, where the graph intersects the x-axis. Where the graph of cubic polynomial intersects the x-axis, that points are called zeros of the polynomial. Here some example we have taken for explanation. Y is equal to x cube minus 4x. Similar fashion as fashion of previous examples, we form a table by substituting the x value, we get the y values. From those two, we got the points. From those points, we form the graph. So here, by substituting these values, what we get? X is equal to minus 2, we substitute, we got x is equal to minus 2 comma 0. X is equal to minus 1, we substitute x is equal to minus 1 comma 3. X is equal to 0, we substitute y is equal to 0. X is equal to 1, we substitute, we got y is equal to minus 3. X is equal to 2, we substitute, we got y is equal to 0. These are the 5 points we got. So by substituting all these points, minus 2 comma 0, minus 1 comma 3, 0 comma 0, 1 comma minus 3 and 2 comma 0. Okay. So by combining all these, we got the graphical representation is like this. Okay. And from graph we observe that it touches the x-axis at minus 2 comma 0 and 0 comma 0 and 2 comma 0. And from the table also we take x is equal to minus 2, then y of minus 2 is equal to 0 and x is equal to 0, then y of 0 is equal to 0 and x is equal to 2, y of 2 is equal to 0. For these three values, minus 2, 0 and 2, we got this expression y 0. So these 3 points are called zeros of the polynomial, cubic polynomial, because in one case the value of y at these 3 points is 0 and in another case the graph also saying same thing, that is the graph touches the or intersects the x-axis at these 3 points. So these 3 points are called zeros of this cubic polynomial. So what are the 3 points? Minus 2 comma 0, 0 comma 0 and 2 comma 0. These 3 points are called zeros of the polynomial y is equal to x cube minus 4x. This explanation is same. We see from the table above that minus 2, 0, 2 are the zeros of the cubic polynomial x cube is equal to minus 4x. Observe that minus 2 comma 0 comma 2, in fact x coordinates are only points where the graph intersects the x-axis. This graph intersects the x-axis at these points. Since the curve meets the x-axis, only these 3 points, these x coordinates are the only zeros of the polynomial. So in this graph touches the x-axis at only 3 points. So generally for any cubic polynomial, the maximum possibility of these zeros is 3. That is, maximum number of zeros possible for a cubic polynomial is 3. Okay. This is the different cases, like we have seen in previous cases, 1 0 case, 2 0 case and non-zero case. These are different cases. Here y is equal to x cube. In this case we have only 1 0. Okay. We have only 1 0. Y is equal to x cube means all these 3 are same. All the zeros are same. X is equal to 0, x is equal to 0 and x is equal to 0. These are the only possible case. That means all 3 zeros are same. That is x is equal to 0. Okay. And this is the 2 zeros case. Y is equal to x cube minus x square. One case is 0 and another one is 1. So it is having 2 zeros. 2 zeros case is y is equal to x cube minus x square. 3 zeros case we have seen here. This is 3 zeros case. So we have 1 0 case, 2 0 case and 3 zeros case. So what is the possibility? From the above examples we see that there are at most 3 zeros for any cubic polynomial. In other words, any polynomial of degree 3 can have at most 3 zeros. Understood now? So if the polynomial is having degree 3 means it is called cubic polynomial. For that maximum number of zeros are 3 only. Maximum number of zeros are 3 only. So from the three expressions what we got for linear polynomial, we got only 1 0. Okay, only 1 0. For quadratic polynomials at most we got 2 zeros. Quadratic polynomials at most we have 2 zeros. For cubic polynomials we have at most 3 zeros. For cubic polynomials we have at most 3 zeros. So from these three what we conclude that in general given a polynomial p of x of degree n, if a polynomial p of x of degree n, then the graph of y is equal to p of x intersects the x-axis at most n points. Okay, intersects the x-axis at most n points. That means the polynomial p of x of degree n has at most n zeros. Okay, it intersects the at n points. That means maximum. These are the maximum, not minimum. It is having n number of zeros. Okay, p of x of degree n having maximum of n number of zeros. Okay. So for linear we have 1 degree 1 0 1. For quadratic we have degree 2 number of zeros n 2. For cubic we have degree 3 and number of zeros 3. These are the maximum values. Okay. Here if we see example, look at the graphs in figure 2.9 given below. Each is the graph of y is equal to p of x, where p of x is a polynomial. For each of these graphs find the number of zeros of p of x. Okay. So from this graph how can we say that number of zeros of the polynomial? First we take the graph and search in the graph where the graph intersects the x-axis and at how many points it intersects the x-axis. That is nothing but the zeros of the polynomial. So here in the first graph we see this, it intersects x-axis at 1 point. So what is the 0? 1. Only one number of 0 is there. Here it intersects at 2 points. So number of zeros 2. It intersects 3 points. 3 or 4? Don't confuse. Only 3 points. Take only this graph. Okay, 1 point, 2 point, 3 point. So here number of zeros 3. Here it intersects x-axis at only 1 point. So number of zeros 1. Here it intersects at 1 point. So number of zeros 1. Here see this graph different 1, 2, 3, 4. So at 4 points the graph intersecting the x-axis. So number of zeros 4 zeros are there. Okay. Like this, by seeing graph itself we can say how many number of zeros exist for the polynomial. Okay friends. So this is the some exercise problem. Here the graph of y is equal to p of x. See some polynomials and we need to take the call on number of zeros. Okay. Here this graph does not intersect the x-axis. So number of zeros are 0. Here at 1 point it intersects. Number of zeros are 1. Here 1, 2, 3. At 3 points. So number of zeros are 3. Here at 2 points. This point and this point. So number of zeros are 2. Here how many points? 1, 2, 3 and 4. So number of zeros are 4. Here 1, 2, 3. So number of zeros are 3. Okay. Like this, by seeing the graph where the graph intersects the x-axis, by calculating all those points we will get the number of zeros of the polynomial. Okay. Understood friends? Okay. So we have now covered geometrical meaning of a zeros of the polynomial, and for the three cases we have seen, for linear polynomial, quadratic polynomial and cubic polynomial. For linear polynomial, what is the general expression? Ax plus b is equal to 0, and what is the value of 0? Minus b by a comma 0. Okay. So ax plus b, where a is not equal to 0, it is linear polynomial. Linear polynomial. Okay. In this, what is the value of 0? Minus a comma 0. How many number of zeros are exist maximum? How many number of zeros? How many number of zeros? It is having degree 1. Degree 1. So maximum number of zeros are 1. Next, for quadratic polynomial. And what is for this linear polynomial? What is the graph? Graph is a what is the graph? Graph is a straight line. What is the graph? Graph is a straight line like this. Okay, for a linear polynomial, graph is a straight line. For quadratic polynomial, what is the general expression? Ax square plus bx plus c, where a is not equal to 0. What is the degree of the polynomial? 2. So maximum number of zeros exists. Maximum number of zeros are 2. What is the shape? Shape of the graph? It is a parabola like this or like this. If a is greater than 0, it is like this. If a is less than 0, it is like this. So what are the maximum number of zeros exist? 2. Okay. Next, for cubic polynomial. Cubic polynomial, what is the expression, general expression? Ax cube plus bx square plus cx plus d. What is the degree here for cubic polynomial? Degree is 3. Okay, maximum number of zeros. Maximum number of zeros for polynomial of degree 3, maximum number of zeros are 3. That means we can get 0, 1, 2 or 3. Any possibility is there. Okay, maximum number of means 3. Here for quadratic it is 2. For linear it is 1. Okay. For this graph is, it is in any form like this. It is in any form. Okay. For these two, the graphs are possible. For this cubic polynomial, we cannot predict the graph. Okay. So like this, we have 3 polynomials are there. For 3 polynomials, what are the expressions, what are the zeros, and what is the degree of the polynomial, and what is the shape, and how that shapes are forming by using that polynomial here. Okay. These are the topics we have covered in this. If any doubts are there, please mention in the comments. Okay friends, thank you. Please like and subscribe my videos. Thank you friends.